Now for this problem, we're meant to flip at least one head on 8 flips. Now remember that for flipping a coin, we have 2 outcomes, heads or tails. There are 8 total events. And if we flip a coin 8 times, there's the possibility that none of them will come up heads. However, 1, 2, 3, 4, 5, 6, 7, or all 8 of them could come up heads. Now we want at least 1 heads, so that's going to include every number from 1 to 8. But look at what that leaves out. The only thing left out is finding 0 heads. So we're really taking all the possibilities except 0 heads. So really, let's try to find the probability of getting 0 heads. Now, if we have 0 heads, that also means that we have all tails 8 times in a row. So let's try to calculate that probability. So, if we're trying to find the probability of getting tails, we'll say that the number of matches is still 1, and for flipping a coin, for one event, we have still only 2 outcomes. So we can say our probability is still equal to the number of matches divided by the number of outcomes. But then, if we intend to flip tails 8 times, we can say our number of events is 8. We'll move this down to make some more room to do the math. And we'll say our probability of 8 tails is going to equal the probability of flipping a single tail raised to the number of events. Again, shift 6 is the exponent. Now we click on the 8. Once again, I'll write down the formula on the side. We take the probability raised to the number of events. The probability went here, and the events were here. So now that we know what probability is in this red box, all we have to do to figure out what's in the green is to take 1 minus what's in the red. So we can say the probability of not 8 tails is the following. We'll say equals 1 minus the probability of getting 8 tails. And we get 0.99609. Once again, to get this probability, we take 1 minus the probability of 8 tails. Anytime you see the word not, that's the same thing as 1 minus. So these not 8 tails, the 0.99609, represents what's in the green box, which is what they asked for. We'll make a little more room for the other problems. Part F asks us the probability of rolling a 7 on one die. Let's list the possible outcomes first of rolling that die. So we notice that rolling a 7 is not possible, so we can say there are no matches, but still 6 outcomes. So let's write this in. Our number of matches is 0. Our outcomes are 6. So now our probability of making a match is going to equal the 0 divided by the 6, giving us a probability of 0. Now the probability of rolling a number less than 7 on one die, once again, let's list the outcomes. 1 through 6. Now, which of those are less than 7? Well, we might recognize that all the numbers we have are indeed less than 7. So we can say 6 matches this time, because all of them fit the condition. This is out of a total of 6 outcomes as well. So let's write that we have 6 matches and 6 outcomes. The probability then is going to equal the number of matches divided by the number of outcomes, giving us a probability of 1. Now, let's look at the probability of correctly guessing a 7-digit telephone number. Let's first list our possible numbers that we are allowed to use. Any number between 0 and 9 could be in your phone number. Now, since we have to press 7 buttons, we can say that there are 7 events. And in those 7 events, any of these numbers could match. Now, we don't know which numbers match, but we can say that for each time we press a button, only one of them can be correct. And if we count the number of digits, we can see that there are 10 outcomes per button press. So let's first look at the probability for a single event. If we press a button, the probability of getting it right is going to be 1 match and 10 outcomes. So our probability of having one event match the number is going to equal 1 divided by 10. However, we have 7 events. We have to get 7 numbers in a row correct to have a correct telephone number. Now, let's take our probability raised to the number of events. So, below the number of events, we'll say probability of having all 7 events match is going to equal the 0.1 raised to the 7th power. This gives us a very, very small decimal, but this is to be expected. Pressing random numbers in a telephone usually doesn't result in the number that you had in mind. So it follows the probability should be fairly low.